Hello everyone. Today my presentation is Neurobasis of Working Memory and Brocas Aphasia. Working memory is a concept proposed based on short-term memory by Battery and Hitch. At year 1974, the concept of working memory has extended and enriched the concept of shortcoming in the short-term memory theory. And what is long-term memory? What is short-term memory? When we remember a phone number, we need a short-term memory just for a while. After that, then properly we will forget the whole number. And what is working memory? Like we're doing some calculation, we need working memory. And what is Brocas Aphasia? Okay, for this research, we are related to long-term memory, working memory, and also neural foundation. Battley and Hitch 1974 believed the working memory of the brain temporarily processed and stored information while performing tasks, limiting the resources and capacity of working memory. It should be pointed out that specific information need to be stored temporarily by individuals to complete routine tasks. Although information can only be stored for a few seconds to a few minutes, it is enough for individuals to complete certain tasks. Therefore, working memory plays a crucial role in completing many complex cognitive activities, such as learning, computing, and comprehending language. The term working memory and short-term working memory are often used interchangeably in studies related to memory. Some studies even treat working memory and short-term memory equally. Although the two have similar meanings and concepts, they can still be distinguished by their functional and structural components. Working memory is closely related to sentence comprehension. Therefore, it is one of the major research topics in the sentence comprehension of aphasia patients. Differences in working memory capacity of the aphasic patients have a tendency to influence sentence comprehension outcomes. This study examined the relationship between working memory and sentence comprehension in order to revise the status quo and identify possible research gaps in this field. And let's see. This is some differences working memory and short-term memory. Like time, working memory we can keep and move the data or info, but short-term memory we only can keep it no more than 3 minutes. And the function of working memory is to process data, but short-term memory is just to keep data. We see the models of working memory. Cowan, Elias, and Conway divided working memory into a series of psychological processes. Atkinson and Schifrin and Battery and Hitch constructed different working memory concepts, but the working memory framework throughout literature is quite consistent. The systemic structure of working memory and short-term memory is quite complex. Both studies conducted by Battley and Cowan supported the idea that working memory system included short-term memory system. And Inger, on the other hand, believed that the working memory system was composed of two parts, short-term memory and control processing function. The difference between the composition of working memory and short-term memory therefore lie in the difference in their working methods. Working memory is more dependent on control processing skills than short-term memory. Processing function is not only a maintenance function but also one that facilitated more complex tasks in order to better support memory in cognitive activities. And let's see. Early working memory models are divided into three parts. There is There are phonological lobes, visuospatial sketchup and central executive system, and are explained as phonological lobes. Here is responsible for storage and control sound-based information. It contains two parts: voice storage and pronunciation control. Voice storage can hold voice message for 1 or 2 seconds. Voice control is similar to internal language. Phonological lobe also assists in the process of language comprehension, vocabulary acquisition, and language learning. The capacity of phonological lobe reflects the level of language learning ability in children and adults. And the second one is pronunciation control. For visuospatial sketchpad, it handles visual spatial information. All information can enter the visual spatial sketcher directly or indirectly. The visual spatial sketchpad is important for spatial mission, planning, and orientation in geographic environments. Do-task studies have shown that such a subsystem does assist in working memory. If it requires a subject candidate to use language coding or visual spatial coding to identify materials, it's found that speech activities interfere with one of the subsystems. The visual spatial sketchpad may contain two elements: a visual element which is related to color and a spatial element which is related to location. And the central executive system. The central execution system is the most important but also the least studied system in working memory. It is a system with limited energy and is responsible connecting system and long-term memory. The central execution system is also responsible for the selection of attention of resources and strategies. Baddeley proposed and refined the concept of working memory based on years of experimentation. He believed that working memory referred to the process of performing cognitive tasks, a resource-limited cognitive system that is responsible for both storage and information processing. The working memory model includes the visual spatial sketchpad, control executive system, and phonological lobe is responsible for the coordination of resource and task and processing of language information and the treatment of visual and spatial information. After the early working memory model was proposed, many researchers have validated it. This proved that it is indeed a successful model. However, shortcomings still exist. Therefore, Battery modified the earlier version of the working memory model, and the fourth component was proposed. And the fourth component is episodic buffer. And we see the neural basis of working memory. The research on the neural basis of the working memory mechanism mainly relies on memory impairments in patients with brain damage. There are many related studies at present, but a unified these conclusions has not been made, in part to the complexity of the brain structure and its function, and to the complexity of working memory itself. Working memory needs to process various types of information in addition to hearing, seeing, touching, smelling, and tasting. And the processing of this information is related to different parts of the brain. Therefore, from the perspective of its neutral foundation, working memory is distributed in nature, and many parts of the brain are associated with working memory. Christopher Klings, Spitzer, Roysemer, and his colleague pointed out that the contents of working memory is widely distributed in the cerebral cortex of the perception cortex, parietal lobes, temporal lobes, and prefrontal lobes of the brain. The frontal eye movement area is related to the storage and processing of location, shape, and texture, and the lateral prefrontal cortex and sound tactile texture tuberosity, the storage and processing of natural image, characters, and analog properties are related to the processing of the auditory cortex and sound. The lateral occipital lobe, compound cortex, and shoulder assembly are related to shape and natural image. Early visual cortex and texture, color, motion, position, and color patterns related to contrast and other information. The middle and upper temporal cortex and movement are related to the movement patterns. The postural parietal cortex is related to shape, characters, texture, value, position, color patterns, and motion. The above description shows a preliminary understanding of the distributional characters of the neural basis of working memory. In fact, Lashley, 1929-1950, who had been committed to the study of engrams, had put forward a similar view. He used rats as experimental subject and examined the cerebral cortex before and after resectioning the cerebral cortex. The rats then were conditioned through maze training. It was found that the large area cortical resection significantly impaired the learning ability of rats, but this was not related to the site of the cerebral cortex resection, but was directly proportional to the area of brain resection area. Obviously, learning and memory are not only related to a single cerebral cortex area, but are spread throughout the cerebral cortex. Therefore, Lashley put forward the mass motion theory, suggesting thinking that each cortex in the brain functions as a whole, and the more cerebral cortex regions are involved, the better the effect of learning and memory. And let's see the brain damage and working memory impairments in sentence comprehension. There is a core part of the distribution of the neural basis of working memory, which is the third frontal lobes and also known as Brocas area. Patients with Brocas aphasia are usually accompanied by impaired working memory. A large number of studies have shown that the prefrontal cortex main sulcus area, region 46, is a key area of spatial working memory. This area is connected to the posterior lobe through fiber exchanges. Patients with Brocas aphasia suffer from impaired working memory. Patients with Brocas aphasia face sentence comprehension disorder. The degree of impairment of working memory is directly proportional to the severity of the sentence comprehension impairment. Severity of sentence comprehension refers to the stage when the process of sentence comprehension stops. Sentence comprehension follows the three major stages of psycholinguistic theory, synthetic analysis, thematic roles assignment, and information integration. Federici combined working memory with the process of sentence comprehension to build a comprehensive model of the process of sentence comprehension in three main stages. In the first stage, the Brocas Aphasia patients need to perform speech segmentation and recognition of the language heard. Subsequently, they need to recognize each word and store it in their working memory as speech memory. In the second stage, the Brocas Aphasia patients must assign thematic roles based on lexical syntax and semantic information of the sentence component. In the third stage, the Brocas Aphasia patients must integrate all the information in order to obtain an explanation of the meaning of the entire sentence. And in 1992, Just and Capital had explored the relationship between sentence comprehension and during sentence comprehension. Both the capacity of working memory is eroded. In this case, working memory resources may affect sentence comprehensions as there are individual differences in working memory capacity. Just and Carpenter, 1992, found that these individual differences had a substantial impact on sentence comprehension. If a Brocas Aphasia patient's working memory capacity is large, his ability to process sentence comprehension will be better. Working memory is the internal cause and sentence comprehension is external manifestation. Different degree impairments of working memory. Patients with severe aphasia who have impaired working memory may not understand certain sentences during the first stage, syntactic analysis. In level working memory impairment, unable patients to understand sentences during the second stage. Thematics arose aside, and minor level may age in complete sentence comprehension during the third stage, information integration. From the stage to the second stage, and then from the second stage to the stage. More participation can complete some sentence fully sentence comprehension. This is because simple sentences need just more capacity of working memory to process sentences. For example, sentences. For complex sentences, they may not be able to successfully complete the three analysis. More cognitive resources are needed to be used to analyze sentences, but because working memory is impaired, sufficient cognitive resources cannot be provided. In conclusion, the neural basis of working memory is found mainly in the brain frontal lobe, especially around the Broca area. The main problem aphasia is that the Broca area damage. Damage to this part of the brain will affect the working memory capacity of the patient. Working memory refers to working memory capacity that can be measured through a general reading span or other measurement methods and is quantified through a general cognitive area. Working memory capacity refers to the total amount of working memory resources required to complete a cognitive task that is the total amount of working memory. Okay, that's all my presentation. Thank you.